start then. So last time we have seen some examples. I will start with one more example. Actually, maybe two more examples related to total probability and bias formula. So let's. This is about total probability. What was it? Let me just remind you real quick. It was this. Suppose you have a partition of your sample space omega into finitely many subsets b1 up to bn. So these are disjoint sets whose union is equal to omega. Then of course any subset of omega can be written as the disjoint union of the intersections of A with these subsets. And since these are disjoint, the probability of A will be just the sum of the probabilities of these disjoint sets. And that's called the theorem of total probability. And using this, we had also this bias formula in terms of conditional probabilities. Okay. Now let's see our next example. Let's assume that k earns are given. Let's say u1 up to uk, where uj contains mj white and nj black balls. Okay, for j from 1 up to k. Take at random and earn, and we ask the following: what is the probability to draw a white ball, one white ball from that yani kavanozlardan birini alıyoruz rastgele ve onun içinden rastgele bir tane top çıkartıyoruz. Onun beyaz olma olasılığı nedir? Okay, so what is the solution? Well, we will make use of our theorem, actual formula for total probability. Let us define the following probabilities. Or events. Let A be the event of taking one white ball, and similarly let BI be the event of taking the ith urn. So the probability of taking the ith urn is, let's say, BI. That's the event, sorry, BI. And taking a white ball, the event of taking a white ball from that urn is A. Then the total probability then by the theorem of total probability, we have the following. The probability of A is just the sum from 1 up to k of the conditional probability of A given Bi times Bi. Okay, now this is the intersection of A and Bi divided by probability of Bi and taking the yes burada tabii okay yeah, although I use the same notation, actually we have to be careful. Belki burada yeah, maybe I should write like this here. So this is taking a white ball from the urn Bi. What is the probability? It is just Mi, the number of white balls in Bi, divided by the total number of balls in the urn Bi, which is Mi plus Ni. And what is the probability of taking the ith urn? Well, we have k urns, right? K urns, U1 up to UK, and picking an urn has equal probability for each of them. Therefore, this is just 1 over k. So this thing is just 1 over k times I from 1 up to k, mi plus ni. Yeah, here I guess one has to use a different notation to distinguish oh, okay, let me think about it. Burada neyse onu sonra düşüneyim. Değil mi? Yani bunu PA intersection yok. Yani PA intersection BI or BI diye yazarsak o zaman cancel ediyor gibi gözüküyor ama öyle olmaması lazım. Yani o yüzden notasyonda bir sıkıntı var ama neyse onu nasıl fix edeceğimi daha sonra söyleyeyim. Biraz düşünmem lazım. Okay, another example. Suppose that there are three chests A1, A2, A3, and each having two drawers, so that one contains one gold in each drawer, uh, one contains one silver coin, in each drawer, and one contains one silver uh, in one coin in one drawer, and one gold coin in the other drawer. So we have three chests. In one of them, one of the drawers contain, actually two, both of them contains gold coins. The other one, in the other one, both drawers contain one silver coin, and the third one has one gold coin in one drawer and one silver coin in the other drawer. All right. Let A1, A2, A3 denote the events. The above uh, described chests are chosen respectively. So picking the first chest is the event A1, and so on. A chest is chosen at random, and a drawer is opened. If the drawer uh, contains a gold coin, what is the probability that the other drawer also contains a gold coin? Okay. Anlaşıldı mı? All right. Well, we may regard the events A1, A2, and A3 as disjoint events, and omega is the disjoint union of these. So A1, A2, A3 is a partition of the sample space omega. Therefore, okay. Therefore, PEI is just 1 over 3 for I1, 2, 3. Picking the ith chest has probability 1 over 3. So each of them has the same probability. Okay. Now let B be the event that the coin the coin observed was gold. Then we have what? P B A1 is 1. P B A2 is 1 over 2, and P B A3 is 0. Well, because the chest A1 has two gold gold coins in each drawer, so the probability of B given A1 is 1, right? Both of them are both drawers contain gold coin. In the second one, one drawer has gold and the other one has silver coin. Therefore, the probability that the observed coin will be gold is 1 over 2. And in the third one, both drawers contains silver coin. So the probability of the coin observed is gold is 0. All right. The problem asks for the probability that the second drawer has a gold coin, given that there was a gold coin in the first. Değil mi? İlk çekmeceyi açmışsınız. Altın çıkmış. İkinci çekmeceden de altın çıkma olasılığı nedir, right? The first drawer has gold coin and you ask the probability that the second drawer has also a gold coin. This is of course possible. This is possible only if the chest chosen is the first one, right? Both drawers should have gold coin. Hence, the problem is equivalent to compute P A1 B. Okay. Yani A1'ı so given B means the first drawer has gold coin. What is the probability that you have chosen the chest A1 at the beginning, right? So by the Bayes formula, this probability P A1B is equal to what? This is PA1, PBA1, right? Bayes formula just replaces the places of A and B's, right? Sum over AI P times BAI. Well, the probability of choosing the first chest is 1 over 3, and this probability is just 1 because both drawers has gold coins. And what is this? This is 1 over 3 times 1 plus 1 over 3 times 1 over 2 plus 1 over 3 times 0, and the total okay, the computation gives us just 2 over 3. Okay. Evet. Aha, öyle mi? Ee, ama orada işte PBI dediğimiz şey yani emin değilim ya. Bir düşüneyim onu. Şu anda hani şey yapamıyorum. Okay. Uh, here is a exercise for you. So continuation of the above example. Compute the probability that the second drawer has a silver coin, given that the first drawer had a gold coin. Okay. Now let us start a new concept, studying new concept. Independence of events. So when do we call two events independent? Here is the definition. Two events A and B are said to be independent if the intersection, the probability of the intersection is the product of the probabilities. Okay. Example. Okay. So let, for example, omega A P be the probability space of tossing a coin. Sorry, tossing two die. Assume the classical scheme. So each phase has equal probability and so on. Okay, that PA is just the number of elements in A divided by the number of elements in the total sample space for all A in A. Değil mi? Yani so the die is an honest die, right? Each phase has equal probability, which is 1 over 6. Therefore, for an event, the probability of that event to occur is just the number of elements in that event divided by omega. Okay, so let us define the following events. Let A1, for example, be the following. 1 appears on the first die, and A2 is the event. 2 appears on the second die. Okay. Now, what is the probability of the event A1? Okay, now A1, the set A1, so this is PA1. Okay, so this is just the number of elements in A1 divided by omega. The number of elements in A1, so this is the number of pairs, right? Number of pairs, 1 comma something. Here, how many such pairs we have? Well, we have 6 pairs, because when you throw 2 dice, the first one will have 1, the second one may have any number. Therefore, there are 6 elements in A1. What about the number of elements in omega? Well, there are 6 times 6, 36 pairs, right? So this is 36, therefore this is 1 over 6. And similarly, PA2 is this. Well, this is the same thing, right? Basically. So the probability is again 1 over 6. What about PA1 intersection A2? This means the first die will be 1, the second die will be 2. Well, there is only one such pair, right? Which is 1 comma 2. So this is just a set containing one pair, 1 comma 2. So the intersection is just 1 divided by the number of elements in omega. İsterseniz şöyle yazayım. A1 intersection A2 and then omega here. So this is 1 over 36. And you see that this is just the product of these probabilities. Therefore, the events A1 and A2 are independent. Okay, hence the events A1 and A2 are independent. Okay. Of course, if you just think about this, you are throwing 2 die. I mean, it doesn't matter, right? What the first one shows for the second die to, show, right? I mean, they are independent events. Okay. We will study this theoretically, but for that we just need some simple facts. First one is this. If we have two independent events, so if A and B are independent events in our sigma algebra, sorry, A, then so are A complement B, A B complement, and A complement B complement. So these three pairs, belki şöyle mi yazayım? And A complement and B are independent. A and B complement are independent, and A complement and B complement are independent. Okay. So they don't communicate these two events. Okay. They have no link between them. Yani A olayının olması için B olayının olup olmamasının bir önemi yok, değil mi? Onu söylüyor. B ister olsun ister olmasın, A'nın onunla alakası yok. Well, here is the proof. Let's prove one of them. The rest will be similar. Let's prove only the first one. The other ones are similar, so that's why I won't do them. What is PA? Well, PA is the same thing as PA intersection B union B complement. Why is that? Because B union B complement is omega, and A is of course equal to A intersection omega. But when you write it this way, we can write the following. This intersection is the disjoint union of these two events, right? Because B and B complement are disjoint. So I can write it this way. And here, well, since they are disjoint, I can write this as the sum of the probabilities. Okay. Since they are disjoint, the events are disjoint. All right. And from this, we can write the following. P, A, B complement. Çok yaşa. This is PA minus PA intersection B. And this is PA minus, since A and B are given to be independent, this probability is just PA times PB, right? And this is just PA times 1 minus PB. And what is 1 minus PB? This is the probability of B complement, right? Because B and B complement is a partition of the sample space. Therefore, the sum of the probabilities of PB and PBC is equal to 1. Therefore, 1 minus PB is just PB complement. So what we have seen is then the probability of A intersection B complement is just P A times P complement. Hence, A and B complement are independent. Okay. Yani independent demek iki tane olay var. Birinin olup olmaması diğerini hiç ilgilendirmiyor. Onun ondan haberi yok. Okay. Some remarks about this concept. Omega is independent from any event. So the whole space, sample space, is independent from everything. Why is that? Because, what is this probability? Well, this is just PA, but this is just PA times 1 actually. And this is PA times P omega. Okay. Therefore, this intersection is the product of these two probabilities. Therefore, A and omega are independent. Similarly, empty set is independent from any event. Why is that? Well, PA intersection omega, empty set. This is just, of course, the empty set, and it is just 0. And 0 is just 0 times or PA times 0. And 0 is just the probability of the empty set. Therefore, this probability is equal to this probability. Hence, A and the empty set are independent. Third one, if A is an event independent from itself, then the probability of A is either 0 or 1. Yani kendinden bağımsızsa o zaman o ya probabilitesi sıfırdır ya da birdir. Neden? Why is this? Well, let's see. Okay, so we assume that since A is independent from itself, this probability is equal to PA times PA. But on the other hand, this is just PA, of course, because A intersection A is PA. Therefore, we see that PA minus PA times PA is 0. Well, this means PA times 1 minus PA is 0. These are real numbers. Two real numbers. If the product of two real numbers is 0, then one of them should be 0. So then either PA is 0 or PA 1 minus PA is 0, which means PA is equal to 1. Okay. I cannot say that A is empty set or the whole space, because A could be something which has probability 0, but it doesn't have to be the empty set, right? There are sets or events whose probability is 0, but they may not be the empty events. Okay, here is another definition. Given events, let's say A1 up to AN, they are said to be mutually independent if for every possible subset of K, here K is between anything between 2 and N of the events A1 up to AN, we have the following. The probability of I1, AIK is PA1, I1, PAI1, and product with PAIK, where 1 between I1, I2, IK equals, less than or equal to N. So what you do, when we are given events A1 up to AN, we will call them mutually independent. If what happens, I just take any K of them and look at the intersection, and this intersection has to be the product of the probabilities. The probability of the intersection should be this product for all choices of I1, I2, IK between 1 and N. Okay, so this is a very strong actually definition. Okay, all right, let's have a break now. It is 23. After the break we will continue.